the class, let me tell you two important things. First of all, there will be homeworks in the given class. So it is your job to solve the homeworks and send to me. Even if you do not able to solve the homeworks, at least you write down the homeworks in a paper, and after that you send to me. That way I shall take your attendance. Now, in the first two chapters, we have learned about matter, whether they can be found in pure or in other not pure forms. In the second chapter, we already gained knowledge about elements and compounds. So, it is time to go much deeper. So, the chapter shall be called atoms and molecules. So, a chemical reaction, you see, is very rampant in nature. So, elements may combine in variety of ways to give you a compound, and the same compound may decompose or break to produce these elements which may go back to the nature. So all these chemical processes or chemical changes is governed, the various aspects of these chemical reactions is governed by some rules. In fact, there are 5 rules, but today, as per your curriculum, we are going to study first 2 rules, which are law of conservation of mass proposed by Lavoisier, which was a French scientist. Another is law of constant or definite proportions. It was a law proposed by Proust in 1799. So let us see how these 2 laws govern various aspects of a chemical reaction. You may have heard of it, law of conservation of mass. Suppose A and B are 2 substances and you allow them to react. So A and B shall be called reactant. Now if they combine or react to produce C and D, this C and D shall be called product. Now when you allow A and B to react, you must have taken some weight of these 2 reactants. So after the reaction, when C and D is formed, you can measure the weight of this product. Now the thing is, mass of A plus mass of B, which is the combined mass of the reactant, is equal to mass of C plus mass of D, which are the combined mass of the product. That means before and after the reaction, no mass is lost. That means no matter is created or destroyed. Another example I may say, let us say 4 grams of hydrogen gas and you allow it to react completely with 32 grams of oxygen gas. So how much water will be formed? It is simple summation of the reactants of their weight. That is 4 gram plus 32 gram, that is 36 gram of water will form. So no matter was created or destroyed in a chemical change. That means mass of a system remains constant. So this is the first statement of the law of conservation of mass, which is in a chemical reaction, the total mass of the reactants is equal to the product formed. So here goes the first law. Now let us see the laws of constant proportions. Now this is very interesting. Say we take the first example again, where hydrogen gas reacted with the oxygen gas and it has produced water. The first line. In the second line, we mention their weight taken. So hydrogen gas was taken 4 gram, oxygen gas was taken 32 gram. So the ratio is 4:32, that is 1:8. So and it produces 36 gram of water. Again, if you take 20 gram of hydrogen and 256 gram of oxygen gas, they also have reacted in 1:8 ratio, that is 20 gram is to 256 gram, and you get 276 gram of water. There is no reactant left in the reaction chamber. So in a complete reaction, if you are to produce a certain substance, compound or whatever, the reactant must combine with a constant proportion or constant ratio. So where in everywhere you go, in whatever chemical process you employ, the hydrogen gas and oxygen gas must react in 1:8 ratio by their weight to produce water. So we may say the elements combine together in a fixed ratio to produce the same kind of compounds. So how can we justify